Hey everyone, today we are diving into one of the most fascinating aspects of machine learning, model interpretability. Have you ever wondered why your machine learning model makes a certain prediction? Well, I've got you covered with three powerful techniques: shape, lime, and partial dependence plots or PDPs. Let's start with a quick question. What is model interpretability and why is it important? Interpretability is all about understanding why a model makes certain predictions. Whether you're working with a credit scoring system, a medical diagnosis model, or just exploring data, interpretability builds trust and helps you debug models. First, we have Shapley additive explanations. Shape uses concepts from game theory to explain how much each feature contributes to a specific prediction. Let's see how Shape works step by step. Here I'm using California housing datasets. After training a simple XGBoost model, I import the Shape library and initialize an explainer with the training data. Now, here's the magic. Shape values gives us a breakdown of how much each feature impacts the model's predictions. This summary plot shows that the median income is the most important feature for predicting house prices. The cool part is, shape values are consistent and fair. Whether you are explaining one prediction or the overall model, shape has you covered. Next, we have LIME, which stands for Local Interpretable Model Agnostic Explanations. Unlike shape, LIME focuses on explaining a single prediction at a time by approximating the model locally with a simple interpretable model. Here's how it works. After splitting the data and training a random forest model, I use LIME to explain why the model predicted a certain house price for one example. LIME breaks down the prediction into feature contributions, showing which features push the price up or down. This table explains the model's decision in simple terms. Use LIME when you need to explain individual predictions, perfect for debugging or communicating results to non-technical stakeholders. Finally, let's talk about partial dependence plots or PDPs. These plots show how a feature impacts the model's prediction on average, keeping all other features constant. In this example, I'm plotting the partial dependence of median income. Notice how the curve shows that an income increases, house prices also tend to increase. PDPs are great for understanding global trends in your model. So, when should you use each method? Here's a quick recap. Shape. It's your go-to for both global and local explanations. Lime is perfect for explaining individual predictions. PDPs are best for understanding how a single feature or feature interactions affects predictions. These tools are incredibly powerful for building trust in your model and making better decisions. I hope this video finds you well. That's all for today. Thanks for watching.